calculator ones, and then we'll have a couple of calculator ones. So when I say they go really fast, look at number 16. Number 16, you absolutely should not have to spend much time on this guy. What is our amplitude? Pay attention now to how it's situated. 3. Amplitude's 3, and the period 8. One hill, one valley. So the answer is B. So easy. All right, now the next one goes on for a couple pages, but this is what I mean. I've been talking about you aren't going to have to actually make a graph yourself, but you have to understand them. So take a look at the equation. It is backwards of how I normally write them. I normally write 2 plus 3 cosine. So this is 2 plus 3 cosine. So you know what about this shape? It's going to have, so Lima-san, all these are forms of Lima-san. But because it's a 2 plus 3 cosine, it's going to have a loop. And the loop will be 1. So find a picture with a loop that's 1, it has to be D. See how easy that is if you understand the shapes. Okay. Now, the next one, we want to find all the values. Be careful between negative pi and pi. That's different than usual. Where cosine is greater than negative 1/2 and sine is greater than root 3 over 2. And that's an and, which means it has to be both. So these are both pretty easy equations to solve. Cosine, I got to be careful because my domain is, for this problem, is from here to here, right? I'll just erase all the rest of it. Okay, now, where is negative 1/2? Negative 1/2 is right here. So here and here, the cosine is negative 1/2. Would you agree with that? What are those angles? What angle has a cosine of 1/2? But it's negative, so it would have to be 2 pi over 3, and this would be negative 2 pi over 3. We don't usually think about it like that. We usually think of it as 4 pi over 3. Everybody okay with that? And I need to be bigger than, so I'm looking at this right here. So if I look at my x-axis, I'm from negative 2 pi over 3 to 2 pi over 3. That's the part that's shading. Everybody okay with that? Now, where is the sine bigger than root 3 over 2? Well, in the same interval. So here's pi, here's negative pi. Here's root 3 over 2. Here and here. Those are only 2 places. So where is the sine root 3 over 2?
2 pi over 3.
Pi over 3 and 2 pi over 3. And where am I bigger than that? Right there. So this one was everything between negative 2 pi over 3 and 2 pi over 3. That one's everything between pi over 3 and 2 pi over 3. So both would be right there, right? That's the answer. So that would be D. Everybody good? Now, you might do that a totally different way than I did, and that's perfectly okay. Make sure you're getting the same answer. This is no calculator. All right, a polar function is given by this equation. Okay. is true about the points on the graph. Of our course of data in the XY plane. Okay, well, and we're looking at just 0 to pi over 2. I don't know what you think. I think I'm just gonna go ahead and graph this thing. It's a sine curve. Drop down one. It's gonna start here. And this is pi over 2. So I'm looking at this part of the graph right here, guys. Everybody okay with that? I can't tell. Are you with me? Okay. So which is true? The points on the graph are above the x-axis. Cross it off. A's wrong. There aren't any points above the x-axis. Done. Points on B. Done. C. The points on the graph are below the x-axis and are getting closer to the origin. Now remember, when we translate from polar to rectangular, this is the polar, right? Right here. So what's happening to those points? They're getting closer to the origin. In fact, isn't R getting smaller? That's what we need. So the answer is C. Anybody have a question about that? Good?
Yeah.
All right, let's get our calculators out now and see what's happening in the next problem. We have some equation given to us. And T is measured in hours. And we want to know how long it takes to go from 0 to 5. Thoughts? Remember, you have a calculator for this guy. Thoughts on what you might do? What'd you say? Well, they say we're talking about T being measured in hours between 2 and 9. Could I graph that horrible thing using an X min of 2 and an X max of 9? Maybe not. Maybe one to even include more than that because I gotta, well, I don't know. Let's go ahead and graph it and see what it looks like. Be careful when you put this in, depending on how your calculator works. I have an old calculator, so I have to make sure my numerator is in parentheses. You probably don't need to do that because you have a fraction. If you're not sure how to put it in, ask your neighbor. All right, I got a graph, and I'm trying to figure out how many hours did it take for the temperature to go from 0 to 5. Okay, so if you look at your picture, does everybody have a picture? I set my window, my X's are 0 to 12, and my mins are -3 to 10, or my Y's, I mean. My X's are 0 to 12, and my Y's are -3 to 10. I chose those Y's because I am trying to figure out how long it takes. This thing comes up and does something like this. Here's where the temperature is 0. Do you agree with that? And somewhere over here is where the temperature is 5. And I want to know how far it is from here to here. All right, so how could I do this? Well, can I find that point? So I'll just go ahead and second calc 0, because that's what it is. And it looks like that point is 5.420253, comma 0. So when is the temperature 0? 5 hours, 5.4 hours. All right. Now this one is where y is 5. Can I find that one? Well, one option is to go ahead and put in another equation, y equals 5, and then find that point of intersection. That's something you know how to do. And I got that x to be 7.7007238. So how am I going to find the answer to the question? What am I going to do? Subtract? Kids, we were at 0 after 5.4 hours. We're at 5 after 7.7 hours. How long did it take us to make that move? Whatever whatever that minus this is. I got 2.280 D. All right. Takes a little bit longer than some of the others, but it's easy. We need to find this point, that's where it's 0. We need to find this point, that's where it's 5. We just have to figure out how far that is apart, x-wise. All right, the table for function exponential regression is used to model the data. What is the value of f of 1.5 predicted by the model? Okay, so first we need to remember how to do a regression on our calculator. Remember how to do it?
You're gonna use
Stat edit, and you're going to put in
the numbers.
L1 will be the x's, L2 will be the y's, and they tell us we're doing an exponential regression. So once you have everything in, stat edit. Remember what to do next? Stat calc. And go down to exponential. EXP. And we're doing L1 and L2. And go ahead and store that as Y. You should have come up with something like this. Is that what you came up with? Anybody else come up with that? Okay, now, here is one of their points of emphasis. If you don't know what else to do, since you have to find the value of f of 1.5, could you just put 1.5 right here and figure out what that is. And chances are that will be absolutely fine, especially if you've carried a few more decimal places. But remember, your calculator will do it for you since you stored the regression equation. If you just type in y parentheses 1.5, or you'll get your y variable, and then 1.5, the calculator will do it for you and avoid all round off. Now, again, if you don't know how to do that and it's going to stress you out, then just plug in 1.5. But the calculator will take care of it for you if you just type that. Is that what everybody got?
Yeah.
So it looks like the answer is A. All right, just a couple more. Looks like we will be done. No, we're almost done. All right, so here we go. The number of minutes of daylight can be modeled by this. Which of the following best describes the behavior on day 150? Okay, pretend this is an exam question. What are you going to do? Any thoughts on that? Well, how about if we type in our equation? Again, be careful, because it's a mess. Okay, did you get it grabbed? I'm still messing with my window here. Okay, so here is what I did. Did you get it grabbed? Okay, so the window, and again, your window isn't anything unique. I went for my X's, I went 100 and 200, and my Y's, I went from 500 to 1,000. Now, I strategically picked 100 and 200 because I want to know what's happening when X is 150. Okay, so I kind of wanted to make sure that was sort of in the middle of my picture. So I've got my picture drawn. Now, if I hit trace, my cursor popped right up at 150. So that is the part of the graph I'm looking at, right there at 150. So answer the question. Is it increasing at a decreasing rate? Is it decreasing at a decreasing, increasing at an increasing? You know what's happening there. Isn't the curve going up still at that point? And isn't it concave down at that point? So what does that mean? It's increasing, but at a decreasing rate because it's concave down. Now, you maybe probably answered that question on your own. Is what I did, does that make sense to you at least? All right, number 23. This thing has a period of 2 pi. In order to find the inverse, which, okay, so to find the inverse, which of these domains would be necessary? Well, let's just graph this thing and see what it looks like. Has a period of 2 pi. I think I'm going to graph it from negative 2 pi to 2 pi, because I see some negative numbers in my answers. And boy, I'm not going to have to go very high on the y, so I'll just do negative 2 to 2. And this equation is sine minus cosine. Like this. I mean, did you get something that looked like that? Okay, tell me why there's no inverse. This thing, as it's drawn, has no inverse because why? There are repeated y values. Remember that thing called the horizontal line test?
Yeah.
What does an inverse do? An inverse flip-flops your ordered pairs. Look at this ordered pair and this ordered pair. I don't know what they are, but don't they have the same y? So when I turn them around, what's going to happen? They're going to have the same x, not good. Okay? So what we need to do is figure out what part of that graph we should be using. Okay? So what do you think? Would you think maybe a piece we could look at would be like from here to here? Would that piece be an inverse or be invertible? Would it have an inverse? Yep. So I need to figure out these x values because they're going to be my domain then that I'm going to use. Okay. So let's look at our options, see if we can narrow it down. I don't think 0 to pi is going to be a legit option, do you? I'm going to rule out C and A. A and C are out. So what about B and D? Well, this must be negative pi over 4, and this must be 3 pi over 4. I'm not even going to find them. That's all I have left. Why? Because B says all possible values occur without repeating, and D says because the length of this interval is half the period. It's B. Isn't that how I know it's B? Because no y's repeat. All right, last one. Don't let it psych you out. It looks way harder than it is. Don't be frightened. The height x can be modeled by a periodic function. At time t is 0, it's at 120. So this is 120. The next time is 8 seconds later. So at 8, it's at 120. It's a periodic function. So can I write an equation for that? The lowest is 20. Okay, so that's not quite right. The lowest is 20, so it looks like this. Okay, so what do you think about that? That looks like a cosine curve, so I'm gonna rule out A and C. Is this 70? So whatever my equation is, it's gonna end in a plus 70? Oh, they all do, so forget that. Okay, what's the period of this thing? 8. So period, remember, is 2 pi divided by b, and that's 8. So b has to be pi over 4. So find the equation with pi over 4, that would be equation b. For tomorrow, I want you to do the first 2 free response. Okay, so you're gonna do number 1 and number 2. Feel free to work on if you wish, but we'll do those. And then tomorrow I will give you the first practice.
Show you the forecast for today.
Yes, when did you do it?